Okay guys, we are continuing about the animation in Matlab. So I'm going to continue with this homework that I assigned to you. As you see here, that's right, plotting a red dashed circle. The radius of 2 centimeters moves from 0 and 0 to 5 and 5. Okay, so I hope that you have done that. If you don't, so let us do this. So guys, I'm opening this. So but before going here, I have to teach you a little mathematics from high school. So you know that a circle equation is like this, that's right? Let me do this. It's like this. So x minus xc square plus y minus yc square is, I hope that is recording, yes, r square. That's right, the magic happens and the color change suddenly by itself. So x of c is the center of the circle and y of c is the y of the circle, that's right. So on the other hand, if you see circle here, that's right, suppose that located at the 0 and 0 is center and it's the radius, that's right, r. And if you measure from this angle is theta, so if you decompose on the x and y axes, this is gonna be what? It's gonna be r what? R cosine theta. That's right. Sorry, sine. I'm getting older, guys. R sine theta, and this is gonna be how much? This is gonna be r what? Cosine theta. So if you assume a point on the circle, so x of p gonna be what? How much? Gonna be r cosine theta, and the y of p gonna be how much? R sine theta. So keep this in mind, because when I'm developing code in Matlab, you'll see how I'm doing it, right? So here we go. Okay, so the problem is I want to develop, let me make this smaller and bring it down to here. Okay, here we go. A red dashed circle with a radius of 6. Okay, so first of all, having that, you can say, so on the other hand, this is for this angle, but if you rotate this angle from 0 and this moves until 2 pi, you're gonna have lots of the points. You're gonna have lots of the points on the circle. So it's enough that I change the angle theta between 0 and 2 pi and have r in hand. That gives me all the x of the circle and all the y of the circle. That's right. That's right. So exactly, I'm transferring this in Matlab. Understand? So what I'm gonna do, I'm gonna say theta, as I taught you previously on the YouTube links, between the point 1 until 2 pi. That's right. And then, because I'm gonna change inside that, I'm gonna say r is the radius gonna be. Problem wants me to generate what? To generate 2 centimeters. So it's gonna be 0.02 in meters, right? It's gonna be what? Always I told you, you have to comment your code. So this is radius of circle, and this is what? This is this is the angle, that's right. Okay, now having that, I have to go through for loop. Because why? Because I have too many points. So I'm gonna say theta, exactly this, that's right. Theta, actually I can put this, the whole as a comment, because we already did this. Okay, So theta between this and this. Now x of p gonna be what? X of p gonna be r in cosine of pi. This is a very good example, guys. And the y of p gonna be what? R sine of what is pi of theta, guys. And this is gonna be sine pi theta. Okay, theta. Okay. So end. So n is 4. And exactly I transfer exactly this to get here, guys. R cosine theta, R sine theta. Okay. So now if I say figure 1, okay, plot plot what? X of p and the y of p, and I say this and the blue and the blue, and hold on, because you have too many points starting from 0 to 2 and you're circling this, right? Let us see what it gives to us. This is a very interesting code because I'm teaching you too many things by this code. So let us see what we get, guys. Oh, I have to say it first. I'm going to say plotting circle, maybe 2. So it's going to give me, see, eventually gonna plot me a circle, guys. Bear with me, that's right. And its radius is how much? As it shows, the radius is 2 centimeters, 0.2, and it goes down and circling, that's right. So, and I taught you how to make a simulation, right? But the point is that the center of this is 0 and 0. And you see, when I'm plotting like this, it's gonna take a long time to plot this, especially that I chose a very small step, 0.01. That's why it takes a lot. So this is circle now you plotted in Matlab, right? So this is too much, guys. Too much. So I'm gonna upgrade my code. I'm teaching you too many things today. Okay. Well, how I'm upgrading that? Let me close this. I'm gonna put this as a comment, the whole 4. This is 1 4, and copy and paste, and I'm gonna Control T, that makes uncomment. Okay, instead of plotting inside the for loop, guys, I'm gonna start putting the counter. Okay, counter is 0. Then I'm gonna say con is equal to con plus 1. It's for instance, this is counter, guys. Just do it at home as example. This is counter for me. Okay, so for theta 0, the count gonna be 1, 2, 3, 4, 5, 6, 3, however what is. Now instead of putting xp, I'm gonna say xp con and yp con. By doing this, I'm generating a vector of xp and y. By I make a vector of xp and yp. How? Let me show you. Pause. I'm putting the pause command I taught you in the YouTube links. That's right. Look at here, guys. It's very interesting. Okay. Let's go to Matlab. It will show to you. See, x is 0.2, 0.2, 0.2, 0.2, 0.2. But see, but it's repeating itself. Okay, and coming. Now it's decreasing, that's right. Until it goes to the negative, that's right. then again eventually goes to be positive because it's cosine, that's right. See, eventually goes to positive. So a generated vector is positive. Is a quarter score, first quarter, second quarter, third quarter, fourth quarter. See, it generates a vector of x and vector of y. That's right. Now you see that it emerged again very rapidly. So if I do this, guys, and now you see that it's gonna be very rapid, and suddenly my figure appears here. It's processing this, right? Oh, there's a pause. I forgot to deactivate pause, guys. Okay. See, okay. First of all, as I taught you several times, always put clear and clear all the parameters of the workspace. So if I now run this, so pops up. Compare this with this code. When you put the figure command inside the for loop, it takes a long time, and using the memory of your computer and slowing down your code. Never put, is my recommendation, the figures inside the for loop. Never ever. But generate a vector of whatever you want and boop, put it there. Now if I, guys, look at here, if I remove this now, what I'm gonna get? So I'm gonna say blue, red, okay? I'm gonna get a solid circle, guys, like this. Understand? Huh? Now, obviously you can have a line width, change it as 2. Here we go. We have a more thick circle that you plotted in Matlab, and very rapidly. Obviously you can put grid and x, y, and y. Now again, I taught you already. I don't want to waste your time with this. But the problem is, it's recording? Yep. The problem is that problem says a red dashed circle with a radius of 2 centimeters. So first of all, it says red dashed circle. Okay, here we go. Dashed. Oh, I have to close this first. Red dashed circle. What moves from 0 and 0 to 5 and 5? X is this, and it's okay. So now the problem is that you have to say from 0 to 5. That's right. So I'm gonna say your x, that's right. I'm gonna say x that is moving. I'm gonna put as 0, and obviously I'm gonna put until to the 5. That's right. So how to do that? So I'm gonna say x is the new x is old x, which is 0, okay, plus I have to generate, guys, the problem says is between 0.5 and 5. That's right. And I'm gonna say, and is 0.5. That's right. Huh? So the step is 0.5. That's right. Moves from 0, 0 to 5, 5. So what it says from 0, 0, guys, and it moves like this, 5 and 5. So you're gonna have y of the center also is changing, guys. I'm gonna put xc, yc. It's gonna be y plus 0.5. Why I'm doing that? Because now, guys, this is, look at here, this is mathematics. I'm writing x of p with respect to the origin, but when the origin is moving by itself, like this, okay? So I'm going to say x of p, this is kinematics and dynamics, that's right? X of p is r cosine theta plus x of c plus y of c. That's right, x of c, y of c. Here was 0, but it's changing by itself, that's right? So x of p gonna be this. Now let us try together to see, do we get the same result? So it's gonna be plus x of c and plus y of c. Okay, first of all, I expect that we don't get the result. Let me run it and you tell me how. Okay guys, here we go. It says, I'm sorry guys, I have to define y, yeah, and the x of c on the line s, c on the line c is 0, and all of them, x of c and the y of c. And let me see what we get. We get ridiculous things, because now you cannot add like this, right? So what's the solution? What's the solution? What's the solution? How we can do that? I'm pausing to give you 2 minutes. Don't go forward and think. Please do that by yourself, okay? Okay guys, so the answer is that this is not possible like this, so you have to change the code. You have to change the code, and you say this time theta is this, okay, theta is this, and now your for loop must be for center of your center of the circle that is moving, that's right. So I'm gonna say y of c is x of c, as the problem says. See here, that's right. Now having that, and we don't need the con anymore, and we're gonna say x of p is this point on the circle, and this, and now we have to move all of them here inside. Okay, so now by doing that, you generate this, but you now x of p is this and plus x of c, and as I said, plus y of c, which is again x of c. That's right. We don't need solve down, because if we solve down, it's gonna be stick there. Understand? And I'm printing this, guys. So, and please do this with me, and you will understand what I have done this. And I don't need count also. That's right. So I say the circle once, your circle, but it's as I said here. Look at here, guys. Oh, get here. This is plus x of c plus y of c. That's right, it's changing. Now if I plot this, you're gonna see this, guys. That's right, but this is not visible. I want to have animation in Matlab. So what you're gonna do, you're gonna say, okay, axis, as I told you in these YouTube links, between 0 and 5 and 0 and 5. X mean x max, y mean y max. That's right. Now if I do this, we're gonna have this, guys. Oh, it's moving. See? Going there. Understand? Now for making it more sensible, I'm gonna reduce this. See? See? It's moving. That's right, it's moving. But the radius is very small, it's 2 centimeters. That's why it looks like that. If I increase the radius, you see that? It's been increased until it reaches to 5 and 5. If I increase the radius was, I don't know, to 0.1, you're gonna see a different shape, obviously. See? But this is because dashed is like that, okay? Let me clean this and make it solid, and I will show you the result. See? So I'm gonna do this. What do I want to do? Oh, I'm gonna do this. See here? Here we go. This is a hollow circle moving from 0 and 0 to 5 to 5. You can put anywhere that you want. Understand? But what if I want that have a completely solid circle, not the hollow one. Okay, so what I have to do with that, and you can change in direction, guys. Don't think it's limited. Say y of c is plus 0.5, 0.1, whatever. See, here we go. This is different trajectory from the previous one. It doesn't go to 5, goes a little higher than 5. See, ends up here, right? Ends up here, not exact 5. See, or I can make it bigger. I don't know, to make it more visible. 7. Please type this code and try it, because only by practicing you will see this is completely different. See? Okay. So, but the problem is that, guys, if I make this step a little, see, moving. Okay. So this is how we move a hollow circle like this. You are defining all the angle, putting the center of the circle in a for loop, and the y of the center of the circle, and then introducing the point on the circle with the radius disconnected from trigonometry, and then plot it. Okay. But now this is the time after you know how to make an animation in Matlab, you have to know about the fill command. Now let us work on a little bigger. Let us work on the fill command. Fill x and y color. Fill command fills any arbitrary area by providing x and y. See the following example. Let us do it together, guys. I'm gonna put this. I hope that you do it at home. And see, I'm saying x is equal to 0, 1, 1, 0, and y is 0, 0, 1, 1. Okay, and now if I say fill x and y and r, what do you expect to see? Yes, a square, no doubt. Here we go. So put the axis, I don't know, minus 2 to 2, minus 2 to 2. You will see a square. Here we go. That's right. Now, how it works, look at it, guys. 0, I'm showing here. Both 0, 0, 1, 1 is x, 1, 1, 0, 0. So this is counterclockwise of the x of a square. If you give a sporadic, you're gonna have a bizarre shape. So 0, 1, 1, 0. Now it's corresponding y's. 0, 0, 1, 1. As you define x, you have to define this y counterclockwise. Or you can start from here and put it clockwise. Or you can start from here, put it clockwise. Or start from here, put it clockwise. That's what I'm talking about. Okay, so this is how we plot a square. So now you can have this. I'm gonna say, make it please blue for me. Here we go. Or make it green for me. Okay. Here we go. Now you can make it what? You can make it rectangle. 1, 3, 0, 0, 1, 3, 3, and 0. That's right. And now it's gonna be 0, 0, 1, 1. Look at here. It's gonna be a rectangle for me, not a square anymore. See, 0, 3, Oh, the axis, I have to change the axis. 1 is 2 to 3. 1 is, this is good. Okay, and now I'm gonna make it 5. Here we go, guys. So look at here, we got the x 0, 3, 3, 0, and this y is 0, 0, 1, and 1. So you see that the fill is very powerful command in MATLAB. Okay, what do you see? Yes, a red square. Also try the following code. This following code is very interesting, guys. 0, 2, 1. Oh, you have 3 corners. That's right. 0, 0, 2, and it says is blue. And I'm going to -4 to 4. What do you expect to see, guys? Obviously expect to see a triangle. Get here, guys? 0 is x, 0, 2, and the middle corner is what? 1. Again, counterclockwise or clockwise, whatever you want. Its y is 0, 0, 2. You have to respect the direction that you are making your figure. So you generated a triangle. That's right. Which yields a blue triangle. Okay. So now let us make the following animation. A red square with side of 1 centimeter moving from 0 and 0 to 4. Challenging, right? Okay. Let me do this for you. Okay. Okay. So we want to make an animation that we want to have a red square with side of 1 centimeter moving from 0 and 0 to 4 and 4. That's right. So ready? Let's go. So I'm gonna say, so all the corners of this square must move. That's right, must move. So I'm gonna generate this a mover. X of moving is between 0 and 0 and 4 and 0, moving horizontally. I'm gonna say 0.1 to 4. That's right. So x of this corner of this, that is 0, 1, 0, this, and because this is centimeter, that's right, I'm gonna put this because you have to change it to meters, right? It's regular without moving, must be like that. Obviously it's y gonna be 0, 0 as I did above, 0, 0, 0.01 and 0.01. That's right. And now if I say figure 1 and fill x and y and red square, here we go, and the end. Okay, but this, let me plot it outside here. You see what I'm talking about. If I plot this out of here, I'm gonna make this comment. What I'm gonna have is just a regular, and there's no animation. That's right, with the side of the 1 centimeter. That's it. But I wanna have what? Animation. So I have to put in a for loop, guys. Okay. So what I'm gonna do? I'm gonna say the x of this is plus x underline m, plus x underline m, because the corners are moving. That's right, x underline m, x underline m. That's right, x are moving, but what the y? Are y moving? No. So then I'm gonna put grid, and the axis, because I want to see the animation, is between 0 to 4 and minus 0.06 to 0.06. Let me see what we have. What expect to see? What expect to see from this animation? Let us see. Oh yeah, it is moving. But you see, this is very narrow the side. So because I'm gonna do this, guys. First of all, I'm gonna make it a little closer. So it is moving. That's right. So animation working. But the problem is that I'm gonna make it a little slower, and now I'm increasing the size of the sides because it's too small, guys, with respect to the axis that I'm plotting. Right? See? This is square, but compare this axis with this axis. This is your visual error that sees like that. That's what I'm talking about, because this is the scale of the 1 0 to 4 and the scale of this. Look at here. So I increase this. I say to, I don't know, -1 to 1. It gonna look like to what eventually? Yes, it's square. See? It's moving. Your square is moving now. On something like that. Okay. So now we made animation that the red square moving from 0 and 0 to 4 and 0. So if I change also, I want to say from 0 and 0 to 4 and 4, so it's must, you have to have, if you say y of m is equal to x of m, that's right, so you have to move this y of m plus y of m plus y of m plus y of m. What do you expect to see, guys, this time? The square is moving both horizontally and experimentally. So let me this finishes and I will change the axis and you see what's up. Okay. See? If I change the axis from 0 to 4, here we go. You're gonna see a square. This is square. If a solid red completely, not only the hollow square is moving from 0 and 0 to 4 and 4. Or you can now say, you know what, guys? You can give a trajectory, guys. You're gonna say how? You're gonna say if x of m is this, okay? So I'm gonna have x of m1 is sine of, guys, x of m. Oh, I'm gonna know. You're gonna have this. That's right. And now, let me see what I see here, guys. Let me see what I see here. Oh, it's going and backing because it's a sine. That's guys. Look at here, guys. Let me stop it for you guys. Let me change the scale. I'm gonna put -2 to 2. Please do it at home, okay? -2 to 2. What you're gonna see is this. This is too much slow. I want to show you the speed. See? Oh yeah, now it's bouncing. That's right. We can increase it until it shows a decent amount of the oscillations. See here, guys? Now it's bouncing. Right? Now I can make a little more interesting, guys. Right? I can make it y of m is cosine of x of and x of let us see what's difference, guys. This oh yes. See, now the score is circulating, guys, because now this is the equation of what? Let me finish. I teach you. This is mathematics, guys. This is fundamental mathematics that you learned in. This is the equation of what? These two lines? Circle. xm1 square plus ym square is equal to 1. See? Okay. Now the last things that I'm going to teach you here. Now if I say rand 1, oh my god, this time I'm saying the y's of the corners of the square, they are random numbers, okay? And cosine of a random number, I taught you in the YouTube links, right? Let us see what kind of, oh, see? This is how we make fun of the Matlab. This is a random number. This is stochastic vibration of a square. You can use in the ME530. Okay? So the next class, now you have become expert. I'm gonna teach you field 3, and eventually I'm gonna teach you the last topics, eventually ODE solver in Matlab, and how to make fun animations. Thank you.